All right, everyone, welcome back. So last unit was unit 10, which was on perimeter and area. And perimeter and area involve flat two-dimensional shapes. So area, the amount of square units we can fit inside. Perimeter, the distance or length around a figure or a polygon. So for solid geometry, when we're working with solids, we're now going to be working with three-dimensional figures. And another word for three-dimensional figures in geometry is solids. And it's made up of flat or curved surfaces. A flat surface is called the face of a solid, while the edge of the segment, that's the intersection of two faces. Okay, and you can see this example we have here. Here's an edge highlighted in red. It's the intersection of this top face and this side face. And then last but not least, a vertex is a point of intersection of three or more faces. So if this point right here is our vertex, let's do a different color. If this is our vertex, you have three faces that are meeting there. This top face, this side face, and this front face of this solid. Okay? Really, the rest of this first lesson is just going to be practicing naming three-dimensional figures. And before we start naming three-dimensional figures, we need just a base understanding of what some of these common solids are. So we'll start with a prism. A prism is formed by two parallel and congruent polygonal faces and we call those two congruent and parallel faces, we call them the bases of a prism, that are connected by faces that are parallelograms. Okay. We say parallelogram because it doesn't need to have perfect right angles, as you'll see on a couple of these examples. So this specific prism, the two congruent and parallel, remember these would be the two parallel faces because they're not intersecting. These red faces, these rectangular faces, these could not be our two bases because they're intersecting at all three of these edges. As you can see for the two blue triangular faces, they aren't intersecting at all. They're both congruent. These would be our bases. And because the bases are a triangle, we would call this a triangular prism. If the two bases were a square, we would call it a square prism. If the two bases were a pentagon, we would call it a pentagonal prism. And you'll see examples of that on the next page. But those faces that are parallel, they can be any type of polygon. Okay? For a cylinder, hopefully you notice the two bases are now just circles. So our two bases are these two circles. It's formed by two parallel and congruent circular bases and a curved surface that connects the bases. And it's just one curved surface. It's this base, pretty much rectangle. If we open it up and laid it flat, it's this rectangle that's wrapping around the two circles, which would be that curved surface. But once again, this is a cylinder because the two bases are parallel circles. Parallel and congruent. The congruent meaning everything, all the measurements, length, area, perimeter, they're all the same. And the one dimension that tells us that is the radius will be the same on both. Okay, last two, a pyramid. A pyramid is formed by a polygonal base, so it could be any shape. This base here is, we'll just call this a rectangle. Looks like it might be a square, but we'll call this base a rectangle. Okay, so a little different than a prism. Instead of two bases, it's just one base. And triangular faces that meet at a common vertex. So for a pyramid, all of the faces that are not the base are going to be triangles, and you can see those triangles here. One triangular face, here's another, okay. The number of triangular faces is going to depend on whatever that polygonal base is. Here's our vertex. It's where all of the triangular faces meet. Okay. And we name pyramids based on whatever the polygonal base is. So this would be a rectangular pyramid. All right. And last but not least, a pyramid that has a base that is a circle, similar to a cylinder, we call a cone. So a cone is formed by a circular base and a curved surface that connects the base to a vertex. Okay, and we've seen cones before in real life. Literally a construction cone that you set up, ice cream cones. We've seen cones, and you've seen a lot of these 3D shapes before. It's when a pyramid has a base that is circular, still have a vertex. It's where that curved surface connects the base to this point for our cone. Okay. So with this base knowledge, we're going to expand on this with going back to a unit in the past where we've named different polygons based on the number of sides. Now we're going to be naming polygons based on the number of edges for each base. One last thing, when a prism has 6 square faces, we call that prism a cube. And you'll see examples of cubes on your homework and possibly later in this section of notes. Okay, but once again, we're going to go name pyramids and prisms based on the shape of their bases. Okay, so the number of sides. So if you're looking at this first row of examples, all of these blue solids, these are all prisms because there are 2 bases. All of these green solids are pyramids because there's 1 base. And then we name them based on the shape of their bases. So we've had an example of this on the previous page. The 2 congruent parallel bases would be a triangle shape, so we would call this a triangular prism. For this next example, full right angles. We don't know anything about the side lengths, so it could be a cube, but we're not going to assume, so we would just call this a rectangular prism. Okay, when we keep adding more edges, Now we have 1, 2, 3, 4, 5. That would be a pentagonal prism. A polygon with 5 sides, and then a polygon with 2, 3, 4, 5, 6 would be a hexagonal prism. And you could keep going on to have an octagonal prism, nonagonal prism, but we'll just stop there for now. The same goes for pyramids. Whatever the base of the pyramid is how you would name that pyramid. So a triangular pyramid, a rectangular pyramid, pentagonal pyramid. Okay, 1, 2, 3, 4, 5, 5-sided polygon, 1 base, pentagonal pyramid. And then the last one would be a 6-sided hexagonal pyramid. And we're going to practice a bunch of these on a worksheet that you guys have in your notes right after we finish with a couple of these examples here, okay? So what I'd like us to finish with would be classifying each of these solids and then naming some of the vertices, edges, and bases. Let's do the first one together. We'll do A and C together, and then I'll let you pause the video and you can work out B and D on your own. You do not need to list every single vertex and edge because we might run out of room here. But let's just assume this figure, all of the side lengths are the same. Let's assume all the side lengths are the same, okay? Which would make this figure a cube. If you don't have those congruent markings on there, you should probably put rectangular prism, but we'll just put cube for now. Edges, you can name any of these edges on here. AE is an edge. Remember, an edge just connects 2 faces. CD is an edge. Okay, we don't need to name all of them. We'll run out of room here. Vertices just connect 3 faces, so any of these points. H is a vertice. H connects the bottom and these 2 sides, this side and the front. So H is a vertice, B is a vertice, A is a vertice. Every single point on that cube is a vertice. And then the bases, because this is a cube, you could really pick any 2 bases that you want because they just need to be parallel. So you could pick the top and the bottom if you like. You could pick the left and the right side, the right faces of this cube. I'm just going to pick the top and the bottom for now. And remember, the bases, these are planes, so we would say A, B, C, D, and F, E, G, H. Okay? Remember, you can have different answers there. That's okay. Okay, moving on down to C. 2 circular bases. 2 circular bases would make this solid a cylinder. For a cylinder, there are no edges and there's no vertices. And the 2 bases, because they're circles, we briefly talked about this year. When you're naming a circle, we just do a circle with a center in the middle. So circle P and circle Q. Those would be our 2 bases, top and bottom of that can or of that cylinder. Okay, why don't you guys pause the video and you can try B and D on your own. Go ahead. Okay, for B, 5-sided polygon with 1 base would make this a pentagonal pyramid. There's plenty of vertices here. You could have, F is definitely a vertex. Actually, all of these points are vertices. So you could have said F, you could have said B, you could have said A. Remember, a vertice connects 3 faces, so all of those points would have worked. And then again, the same is true for edges. A, B, and D, E. You could have named more than A, B, and D, E or different edges. That's fine. There was only one base here though, so you should have only had one answer here. Base B, A, E, D, C. Order doesn't matter when you're naming a plane. Order of the vertices. Okay, for D, our last solid here, this was a cone because there is one circular base. That one circular base is circle A. Our one vertex here is at point B, and there's no edges. Okay. Why don't you guys go ahead and take out this 11.1 identifying solids practice. It's also under your notes. This is probably the most important part of the first section for working with volume. Where we are identifying or we're naming solids based on the number of bases and then the shape of the base. So what I'd like you guys to do is, these are quick. You're just naming each figure. I can do number 1 with you, and then I'd like you to pause it and name the next 11 of these figures. And then I'll put the answers up after you unpause, okay? But for number 1, 2 bases tell you that this is a prism. And when the 2 bases have side lengths 1, 2, 3, 4, 5, we would call this a pentagonal prism. Okay, that's all you're doing for these, just naming each solid. So why don't you pause the video, go ahead and finish naming each of these solids, and I'll put the answers up when you're done. Okay, so number 2, because the congruent markings are different, these opposite sides are congruent, these opposite sides are congruent, I would make this a rectangular prism. And once again, it's a prism because there's 2 bases that are parallel and congruent. Prism, 2 bases, pyramids, 1 base. Number 3, 1 base, triangular pyramid. Number 4, 1, 2, 3, 4, 5, 6 sides with a 1 base solid would make this a hexagonal pyramid. Okay. Number 5, the 2 bases were trapezoids. I was hoping we would notice with those 1 pair of sides being parallel. These 2 bases were trapezoids, so this was a trapezoidal prism, and it's a prism because there's 2 bases. Number 6, not necessarily a cube because not every single face is a square. Only 2 of the faces, the 2 bases are squares, so we would call this a square prism. Remember, in order for it to be a cube, all 6 faces need to be squares. These bases right here, these thin rectangles, not a square. Number 7, rectangular pyramid. Number 8, 2 circular bases, cylinder. Number 9, 1 square base, a square pyramid. Number 10, 1 circular base, a cone. Number 11, this one we can assume is a cube. Every single face looks like it's this same 1, 2, 3, 4 congruent sides, 4 90-degree angles. 6 square faces would make this prism a cube. And then last but not least, number 12, 2 circular bases, cylinder. Okay. Really, the majority of this lesson, the main learning objective I would like us to have a good understanding of is just naming solids. And the rest of this unit, we'll be finding the volume, the number of cubic units you can fit inside of these solids or these 3-dimensional figures. All right, guys, go ahead and start the homework, and we will have office hours if you have questions.